Here's another example and an overview for an Anova test. Our null hypothesis, again, as stated before, all means are the same. And if there's k different groups, we just have those sub-indexes. The alternative is at least one mean is different from the others. Our F statistic is found by having a ratio of the variance between the groups divided by the variance within the groups. And then we are finding the right tail probability in order to find the p-value. So that's the area beyond the F statistic. Also mentioned last time is the degrees of freedom in the numerator is the number of categories minus 1, and the degrees of freedom in the denominator is capital N minus K. So if in our example over here, we're looking at study times for a sample of 100 students, we have the degrees of freedom in the numerator is, again, we have 3 different groups. 3 minus 1 is 2. The degrees of freedom for the denominator is our sample size, or our total number of people minus the number of groups, which is 100 minus 3 is 97. Our F statistic is 2.14. And in order to find the p-value, we're going to have to use the FCDF as before. So let's look at that. So 2.14. Sorry, it's second vars. FCDF 2.14, certainly much smaller F value as before. We could also see that the groups were very similar. We're going to go to infinity. We did have 3 groups minus 1, and then 100 minus 3 was 97. So our p-value this time is 0.1232. So let's go back over here. Our p-value is greater than our significance level, so we are using a significance level of 0.05. Therefore, we're going to fail to reject the null. And therefore, there is not enough evidence to suggest that at least one mean is significantly different. Just looking at, again, the criteria, the question did give that we have random samples. We're going to assume that these independent samples, 10th grade, is separate from 11th grade, separate from 12th grade, and that there's no dependence between these different groups. By looking at our box plots, we can't really see the shape. However, we can see that based on our sample, there's not a strong skew by simply comparing the different parts of the box plot. So again, that should be fine. And when we're comparing the variance, we're going to look at the spread. We can look at the IQR over here. And again, we can see that there's not really a big difference. And so therefore, all the conditions check. And there is our analysis of variance.